Hello everyone, welcome. A small crowd, but an enthusiastic crowd, correct? Everyone's excited to hear about AI federated learning. So we are going to briefly take you through what we're doing around federated learning, how we're working with some of our partners like byteLAKE, and then we'll go into a little bit more detail. So you're all very familiar with AI, and you probably know, slides are actually running on their own. There we go. So you're very familiar with IoT and what that is. I didn't know it was going to be this challenging. The slides are actually on auto. The slides are on auto repeat. They're just music. Oh yeah. This is the first one. So anyways, I'll just talk through it. So IoT is about collecting data at the edge. There's a lot of data that's being generated at the edge from device data that's remote at various locations. So think of a manufacturing plant where you have all of the machines that are now intelligently connected, right? But how do we derive any intelligence from that data? So IoT in and of itself only provides a certain level of value, but now you have to do something with all of the data that's being created. And this is where AI comes into play. So we're actually using AI to create some intelligence from that data. And actually, thank you. It actually derives some intelligence, right? But there's a limiting factor in that we are restricted by where the data resides. In a traditional architecture, we have to pipe all that data back to a centralized location. And that means that we have to have bigger pipes to get the data out of our facilities. There's also security concerns with moving that data. So where federated learning comes into play is when we create a federated learning model, we're not moving the data, we're only moving the model. So we're doing all of the inference and training on the edge where the data resides, and then just moving a small file, just a model file, back to a centralized location. Now, if you have thousands of devices, and you're only getting a certain level of intelligence from a single device, if we have thousands of devices, how do we allow AI, or the devices to learn from one another, right? So how do we build value off of all of the data across all of our facilities? In federated learning, we send that model to the data center, we combine it with all of the models from all of our edge devices, and we send it back down to the edge devices for inferencing. So we're able to really leverage the value of all of our data, but without the security risk and without all of the connectivity issues that you have in a traditional architecture. So it's a really new architecture. There's some great use cases, but I'm going to allow Marcin from byteLAKE to actually take you through some of the details.
We'll just switch a mic here. Which one goes back in time? The red one? Okay. So let me quickly get back in time to the previous slide. So as Robert mentioned, there are a few things with federated learning. So first of all, we enable IoT devices to learn from each other, but what it really happens, we process the data really close to the place where the data is produced, and then we get AI real-time experience actually for the federated learning. We can go to the next one, and I will briefly tell you how it works in practice. So as Robert mentioned, when you look at the evolution, what is happening in AI actually, right? It started back in the days in the data center or in a cloud level, right? Where you had to send all the data to the cloud and to process it and wait for the responses. We are actually right now moving the AI workloads from the data center, from cloud to the edge devices like this little tiny PC that you see on the slide right now. And we get lots of benefits, right? Like processing the data in real time. We don't get any latencies, so we don't need to send around the data through low throughput networks. But it comes with a cost. when we deploy AI workloads on the edge devices, we all of a sudden end up with having number of edge devices and number of local models, right? So we're asking ourselves the question, is there any way to leverage on all of those AI models produced across the IoT network? And the answer comes with the federated learning, actually. So what we're doing here, we're sending the models to the data center and we're aggregating the models. We're sending back the updates to the edge devices. And once it happens, and with the next cycle of training on the edge devices, we include not only data produced close to the edge, but also the model aggregated from the data center. A key thing here is that we are working with the data on the edge, and the data stay on the edge, but beyond the edge, we just share the models. So imagine Industry 4.0 cases where you either don't have connectivity or connectivity is intermittent, but most importantly, the data cannot leave certain locations like countries, places. And we're actually right now starting with the manufacturing cases, and on my right somewhere there, I would like to invite you after the presentation to see it live for the filters clogging case for factories. But we also get interesting queries from healthcare industry, where you can store the data locally, work on them to analyze the MRIs or images, scanning, but you cannot share the data, right? But sharing the models is a different thing. And we can go to a quickly next slide. This is the demo we're showing there. So there's a little filter in the middle. We're simulating the filters getting clogged gradually by styrofoam pellet over there. And there is a machine learning model running on Lenovo Tiny, powered by Intel CPU, and adjusting in real time, predicting the trends, how the air pressure changes inside this little tube. So this is how it looks like in reality. I highly encourage you to come see the demo. And the big question of 21st century is as John Matson asked once, which black box we should trust, right? And machine learning models turn out to be like black boxes. We trust them more and more, but how can we ensure that we can trust them on the long term, right? So we can, of course, assess whether as machine learning helps us make better decisions on the long run, but the best way, we trust black boxes that are somehow ours, right? So with machine learning, we can actually inject a little bit of our data into the model and get back the results produced by other peers. So Federated Learning, byteLAKE with Lenovo, and the demo is straight there. So let's go there and see the presentation live. Thank you.
Thank you, Robert Diego and Martin Rojek. And as he just said, there's a tube. If you want to have a look, it's just right over there. It's got blue things rolling or something like that. Is that right? Blue things that are blue balls. So go and check it out. And we have our next session at 1.